There we go. Okay, so 1.3, we're going to spend 1.3 and 1.4 talking about radicals and simplifying. Today we're talking about simplifying them when we add and subtract them, and then we'll be multiplying and dividing when we get to the next one on Monday. So this sign that you see here, this is your radical sign, okay? It's not a square root sign, it's a radical sign. It's only a square root sign when you see a 2, like you're taking the square root, or when you see it by itself. That means it's a square root. So this is a cube root, okay? But the sign itself is called the radical. When you see the fourth, that's the fourth root, etc. This number up here is your index, and this is your radicand. I don't test over this kind of stuff, so I'm not going to test you like what's the radicand, what's the index. This is just sort of for your knowledge, and I don't think we typically use that word radicand, but that's what that is. What you really need to be comfortable with is knowing when you see this, y is the nth root of x, okay? So if y is the nth root of x, then when I raise both sides of this equation to the nth power, I know that y to the n equal, and here's a mistake, y to the n is equal to x, okay? So take that off there. So if you think about it, the cube root of 8, I'm looking for a number that I can cube and get 8. What is that number? Cube root of 8. So 2 is the number I can cube and get an 8, okay? So some of these are pretty straightforward to evaluate. Okay, square root of 25. What's square root of 25? This is 5, okay? You know that. Cube root of 8. Cube root of 8 is 2, okay? This is 2. Fifth root of 32 is 2, because 2 to the fifth is 32. Now, those are pretty easy. You probably wouldn't have those on a test, would you? You're probably likely to see something more like this. The square root of 75. Square root of 75, it's not a perfect square, but I know 25 is a perfect square. So I could write this as the square root of what? Yeah, 3 times 25. What's the square root of 25? 5. So this is 5 times what? Yeah, 5 times the square root of 3. So you're going to have to use what you know about square roots, cube roots, and so forth to simplify some of these radical expressions. So again, cube root of 8 is 2. What if I wanted to find the cube root of 16? Okay. Well, 16 is not a perfect cube, but I can write it as what? The cube root of 8 times 2. If I write it as the cube root of 8 times 2, what's the cube root of 8? 2. So this is 2 times what? 2 times the cube root of 2, okay? So that's 2 times the cube root of 2. This is what you need to be very comfortable with in this section, working with the radicals, square roots, cube roots, and simplifying. Again, fifth root of 32, we know that's 2. What about the fifth root of 96, okay? Now, this one I have to think, okay, fifth root of 96. I don't walk around with that in my head. First thing I look at it and say, is it an even or odd number? What is it? It's even. So I can divide it by what? 2. Let me divide it by 2 and see what I get. When I divide it by 2, I get what, 48? What kind of number is that? That's even. I'm going to divide that by 2 and get what? 24. I'm going to keep on going as long as I can. 12, 6, 3. Okay? So what is this? How many 2's do you see here? Yeah. So this is 2 to the 5th times 3. All right? So this is the 5th root of 2 to the 5th times 3. What's the 5th root of 2 to the 5th? 2. So this whole answer is 2 times the 5th root of 3. Okay? So the 5th root of 96 is the 5th root of, it's 32 times 3, or the 5th root of 2 to the 5th times 3. 5th root of 2 to the 5th is 2. And then what I'm left with is the 5th root of 3. Okay? So we're going to have to be comfortable working with these radicals to do these kind of simplifications. Now you notice I left this cube root of 2. I didn't go any further. Why didn't I go any further? What kind of number is the cube root of 2? Is it an integer? Wasn't a trick question, so let's just find out. The cube root of 2. So if I figure out what is the cube root of 2, it is 1.2599. It's an approximation, so it's irrational, okay? So I can't evaluate, all of these can't be evaluated. So this is the square, excuse me, I called it the cube root, but the square root. Square root of 2. 2 is not a perfect square, okay? So I would have to use my calculator to approximate this. Same thing, cube root of -5, fifth root of 3. So in all of these cases, when I see something like the square root of 75, I know 75 is not a perfect square, but I can simplify it by knowing that 25 is a perfect square. So that's the skill we want to work on in simplifying. So let's take a look at a few examples. Simplifying the square root of 50. So if I've got a square root sign, my key to simplification is what's under the square root sign being a perfect what? Square, okay? So the fifth root of 32 is not going to help me in this problem. Why is the fifth root of 32 to the fifth equal 32? Why does that not help me here? I'm talking about fifth roots, but this is what root? This is a square root. So I want perfect squares under the radical. What's the perfect square that I can write this as a factor of? Yeah, it's 25 times 2. So this is the square root of 25 times 2. One of those things is a perfect square. Which one? 25. So this is what? 5 times the square root of 2. Okay? So again, square roots, when I see the square root, my key is I want everything under the square root sign to be a perfect square. Then I can simplify it or pull it outside of the square root sign. Now let's look at this one. Cube root of 54x to the 4th. I'm taking the cube root. My goal is to organize everything under the radical in terms of perfect what? Not squares, cubes. I want perfect cubes under there. Okay, so the cube root of 25 is not going to help me here because that's not a perfect cube. So I need things that are perfect cubes. Now 54, I don't walk around with that one in my head, but I know it's what kind of number? Even. So my first trick will be divided by 2. When divided by 2, I get what? 27. That's not an even number, but I do know it's divisible by what? 3. I move up from 2 to 3. Divided by 3, I get a 9. Divide that by 3, I get a 3. Okay? I'm taking cube roots. I would love to have perfect cubes. Do I have a perfect cube under here? I've got 3 to what power? The third, right? So this is 3 to the third times 2, or 27 times 2. So 27 is a perfect cube. Jack? Question? Okay. So the big key when you look at this, when I look at that and I see cube root, there should be bells going off in my head saying, I want everything to be perfect cubes, okay? So I can write this as the cube root of 27 times 2, that's 54, okay? Now, x to the 4th, how can I write that to where something is a perfect cube? X to the 4th can be written how? X to the 3rd times x, okay? So Naman said we could write this as x cubed times x. Now, what under this radical sign, which of these things are perfect cubes? Yeah, that's a perfect cubed, and that's a perfect cubed. So that means I can simplify by bringing these outside of the radical. What's the cube root of 27? 3. What's the cube root of x cubed? X, okay? So those two things came outside the radical. What had to stay inside? Yeah, 2x. So 3x times the cube root of 2x is as simple as this goes. Okay? So we did some of this last semester with square roots, right? Do you remember that? It's just now we're going to do cube roots, fourth roots, fifth roots. Not a whole lot of different. It's just staying organized. And like I said, the key to everything is what root do you see? This is a cube root. So my strategy is organize everything as perfect cubes. And that helps me to simplify. Okay? So look at the next one. What kind of root am I taking? Square root. So my goal is under the square root sign to have perfect squares. Okay, is 100 a perfect square? Yeah, it's 10 times 10. Okay, is x to the fourth a perfect square? Is there something I can multiply by itself and get x to the fourth? What is it? X squared, okay? So if you're pretty good at it, you can just recognize this is 10x squared, okay? Or if you need help organizing it, you can write it like this. It's the square root of 100 times x squared times x squared. That's what x to the fourth is, okay? So the square root of 100 is what? 10. What's the square root of x squared? X. Square root of x squared is x. So you'll have two x's that come outside of the radical. So your goal is whatever root you're taking, organize what the radicand in, what's under the radical, organize it as perfect squares. If you get a perfect square, you can take the square root and bring it outside of the radical. If you don't get a perfect square, it stays where it is. Okay? Let's look at this one. Square root of 150, x to the 6. Okay, I want perfect squares under the radical. Okay, how can I write this? When I look at square roots and I've got numbers that are like 75, 100, 120, 150, I know that 25 is the key, right? 150 can be written as what? 25. Yeah, it's 25 times 6, is that right? Okay. So that's one way of doing it, if I recognize that. If I don't recognize that, just do what we did a moment ago. 150, that's an even number. I divide it by 2 and I get 75. 75 is not an even number, but it is divisible by what? Yeah, it ends in a 5. Let's divide it by 5. So 5 times 15 is 75. This is still divisible by 5, and that gives me a 3. Okay, so this is 2 times 3 times 5 squared, or 6 times 5 squared, or 6 times 25. So this is the prime factorization of the number. Okay, you've done this in a past life, is that right? Right, Timothy? I'm getting looks here. You're good? Okay. So I can write this as the square root of 25 times 6. Since I'm organizing in perfect squares, x to the 6 can be written as what? That's x squared times x squared times x squared. Okay. So everything, what under the radical is a perfect square now? The 25 and the 3x squareds. Okay. So those can come outside. What's the square root of 25? 5. The square root of x squared is x. I don't have how many of those? 3. And then what's going to be left? The 6. So 5x cubed times the square root of 6. Okay, I think I'm talking fast. I'm going fast. Is that right? It's 5x cubed. So one thing, you got to be careful. That's 5x cubed and the square root of 6. Maybe leave a little space. You know, because sometimes the danger is making that look like a cube root. Okay, so it's 5x cubed times the square root of 6. Okay. Okay, the next one is what kind of root? Cube root. So my strategy will be to organize things under the radical in terms of perfect cubes. Okay. 750, I'm not sure what to do with it, but let's just start out. What kind of number is it? Even number. So let's divide it by 2, and that's, I think I get 375. Any number that ends in 5 or 0 is divisible by 5. So I'm going to go with a 5. So if I divide that by 5, I get 75. Divide that by 5 again, and I get what, 15? Divide that by 5 again, and I get a 3. Do I see anything that's a perfect cubed? Yeah, I see 3 5s, right? So this is 5 cubed times 6. Okay? So I've got the cube root of 5 cubed times 6. How do you think I'm going to write x to the 7th? X cubed? Yeah, x cubed times x cubed times what? Times x. Why did I do that instead of x squared? Yes. So when you look at 750, it's 2 times 5 times 5 times 5 times 3. So 2 times 3 is 6. So 6 times 5 cubed. Okay. So again, why did I write this x cubed, x instead of x squared, x squared, x squared, x? Right, I have 7, but I'm taking what kind of roots? Cube roots. I want everything to be organized into perfect cubes. So now if I look at this, which of these things is a perfect cubed? That, that, and that. So those can simplify and come outside the radical. Everything else has to stay what? Where it is, okay? So what's the cube root of 5 cubed? 5. What's the cube root of x cubed? How many of those do I have? 2. So 5x squared times the cube root of what? 6x, okay? Now another thing you can do when I look at this, I can say you can do this. This is a good way of visually organizing. Another way of looking at it is what happens when I divide 7 by 3? What do I get? 7 divided by 3 is 2 with a remainder of 1. So I get 2 x's and then a remainder of 1. So the more you do that, you can just say, okay, 7 over 3 is 2. I'm going to have 2 x's outside. The remainder is 1. I'll have 1 on the inside. That's more advanced in terms of if you can do that in your head. If you need to organize it like this, that's just the easy visual way of doing that. Fifth root of 96 to the x squared. So my key here is I want everything under the radical to be a perfect what? Fifth, okay? Do you think x squared is anything's going to happen to it? No. I would need to have x to the 5th or x to the 6th or something like that to simplify. So my x's are not going to simplify. I know that. My question is, can the 96 simplify? Okay? So my goal is, I don't know that right off the top of my head, but it's an even number. It's divisible by 2. So that gives me what, 48? Divide that by 2, you get 24. I think we did this one a moment ago. Divide that by 2, you get a 6. Divide by 2 again, and you get a 3. How many 5s are there? Excuse me, how many 2s are there? 5. So this is 2 to the 5th times 3. So this boils down to the 5th root of 2 to the 5th times x squared times 3. Okay? So what's the perfect square there? Excuse me, not perfect square. What's the perfect fifth? 2. So the only thing that comes outside the radical is what? 2. Fifth root of 2 to the 5th is 2. So this is going to be 2 times the 5th root of 3x squared. Perfect. Okay. Okay. So again, we covered exponents, so you'd be comfortable with exponents. Talked about radicals. Now we're just into simplifying. And the key is to know how you organize to see if you can simplify. Let's look at the next one. What kind of root is this? It's a second root, square root. Okay, so I want perfect squares under the radical. The k squared, that's already a perfect squared. I just need to figure out about 108. What do I divide it by? 2. It's an even number, and I get what, 54? Divide that by 2, and I get 27. Now I divide this by what? 3. Divide that by 3 and I get what? 9. Divide that by 3 and I get 3. Okay. Do I see any perfect squares there? I've got 2 squared and I've got 3 squared. Okay. So that's 4 times 9. There's several ways of looking at this. Okay. This is 2 squared times 3 squared times 3. That's one way of looking at it. Okay. You could say, well, this is 4 times 9 times 3 or 36 times 3. Any of those is going to get you what you want. Okay. So which way do you prefer for me to write it under the radical? 36 times 3? Okay, we can do that. Either way. So I can write this as 2 36 times 3k squared. Okay. What's the square root of 36? 6. So this is 6 times 2. What's the square root of k squared? K. What's left under the square root? 3. So this is just 12k square root of 3. Now you would get the same thing if you took this. So if you want to write everything like that, you would get the 2 times the square root of 2 squared, 3 squared times 3 times k squared. The square root of 2 squared is 2. Square root of 3 squared is 3. So you get 2 times 3 times k times the square root of 3. So that's going to be 12k square root of 3. Okay? Pardon me? Well, this is a 2 times this. Okay? So when the 6 came outside, 6 times 2 is the 12. Okay, we're feeling okay with this? Okay. Let's keep moving on. Yeah, I got to get to the adding in a few minutes. Let's skip this one. You can do that one on your own. Let's do this guy. Cube root of minus 32, x to the 8th, y to the 7th. Because of a cube root, I want everything under the radical to be organized as a perfect cubed. Okay? So, if I look at 32, that's an even number. I'll divide it by 2 and I get 16. Divide it by 2 and I get 8. Divide it by 2 and I get 4. Divide by 2 and I get 2. So this is 2 to what power? 2 to the 5th. Okay. Since I'm taking cubes, I'm going to write this as 2 cubed times 2 squared. Okay. Why do I do that? Because I'm taking cube roots. Okay. Now this negative sign out front. What do I do with that? Yeah. So yeah. When you have a negative here, let's think of it this way. What's the cube root of negative 1? What number can be multiplied by itself 3 times and give you a negative 1? Negative 1. So I can just write this as negative of the cube root of 32x to the 8th, y to the 7th. Okay? So when you're taking odd roots and you have a negative inside the radical, what can you do with that negative sign? You can just bring it out. I mean, the 7th root of negative 1 is negative 1 because negative 1 multiplied by itself 7 times will give you a negative 1. So odd roots of a negative, you can just bring that negative outside. So now let's organize what's under the radical. Cube root of, we're going to write this as just, that's what, 8 times 4? That's what 32 is. X to the 8th, I'm going to write this as x cubed, and what? X squared, okay? And then that y to the 7th, I'm going to write that as what? Y cubed, y. Does everyone see why I did all of that? I organized it as perfect cubes because now I want to simplify. So which of these things are perfect cubes? The 8 all these x's and these y's. Okay? So my final answer, what's the cube root of 8? So I'm going to have a negative 2 cube root of x cubed. X. How many of those do you see? 2. So 2x squared. What's the cube root of y cubed? Y. How many of them do I have? I got 2. So 2x squared, y squared. And then what's left? Yeah. Cube root of 4x squared, y. Yes, sir. Okay, that's simplifying radicals. We'll do one more and then we'll move into adding them. Fourth root of 32x to the fifth. Okay. So I want things to be organized as perfect, fourths. How can I write 32 as something to the fourth power? What's 2 to the fourth? 2 to the fourth is 16, but 16 is what? 16 times what? 2 is 32. So that's my key. Write this as the fourth root of 16 times 2, and then I'm going to write x to the fifth, like what? How do I write it? X to the fourth times x. Okay. What's the fourth root of 16? 2. Fourth root of x to the fourth? X. And then I'm left with the fourth root of what? 2x. So 2x times the fourth root of 2x is as simple as that one gets. Okay? That's simplifying. Now we need to add these guys together. So, variable expressions on your left. What do you do with x plus 2x? What is the answer to that? It's 3x. You guys are really on it today. It doesn't hurt that it was written right there. 1 apple plus 2 apples equals 3 apples. That's why you do that. X minus 5x is what? That's just minus 4x. Okay. X plus y, can you add those? No, that's just x plus y. Okay. You can combine like things. Same thing happened with these radicals. 5, the square root of 5 plus 2 square root of 5. This is 1 apple plus 2 apples equals what? 3 apples. My apples here happen to be what? Square roots of 5. So 2 square root of 5 plus 1 square root of 5 is 3 square root of 5. The square root of 13 minus 5 times the square root of 13 is what? Negative 4 square root of 13. Okay, so you can treat these radicals just like variables, like x's, okay? Square root of 2 plus square root of 5 is square root of 2 plus square root of 5. I can't add those together. Don't ever write that as the square root of 7. That's bad math, okay? You can't do that, okay? So these are unlike. This is like adding x and y, okay? You're good with this side on the left. You just have to switch gears when we have radicals and realize the same properties hold. So let's simplify and evaluate this. 3 square root of 2 plus 3 square root of 2 minus how many square roots of 2? 1. What's 3 square root of 2 plus 3 square root of 2? 6. What's 6 minus 1? Yeah. So the answer here is what? That's 5 square root of 2. Okay? So you just treat it like you treat variables. Okay? What about the next one? Yeah, so if you've got 2 square root of 6 minus 2 square root of 6, what's that? 0. So 2 root 6 minus 2 root 6 is 0. And what are you left with? Minus 3 square root of 6. See how easy this is? I'm going to have a feeling it's going to get harder as we move here. There we go. Okay. Yes, sir. Yeah, so if you did that, 2 minus 3 is -1, okay? And then -1 minus 2 is -3. You'll get the same answer. Now, what about this one? Is it 2 apples, 3 apples, and 2 apples in this case? Pardon me? I didn't hear you. I've got to do something here. Can I just add them together, the 2, the 3, and the -2? No, why can't I do that? They're not like terms. So I got to see, is there any way I can get any of these to be alike? So I can write this as 2 times, instead of square root of 8, I'm going to write 8 as what? 4 times 2. Why do I do that? That's going to help me simplify that. Plus 3 times the square root of 2. There's nothing I can simplify on that square root of 2. What about 18? 18 is what? 9 times 2. So minus 2, the square root of 9 times 2. Now, which of these things can give me some simplification? The square root of 4 and the square root of 9. What's the square root of 4? 2. So what am I going to have? What will I have here? This is going to be 4 square root of 2 plus 3 square root of 2. What's the square root of 9? 3. So I'm going to have what? Minus 6 square root of 2. Now can I combine all of those? Okay. So I've got 4 plus 3, which is what? 7. 7 minus 6 is, what's the answer? So that's a lot of work to get to the answer, square root of 2. Okay. But you just use what we did in the first half of the lesson, simplifying radicals so that now you can combine them. Let's look at the next one. 3 square root of 18 plus 2 square root of 5 minus 2 square root of 2. Square root of 5, is there anything I can do with that one? No. Square root of 2, anything I can do with that? Those are never going to combine. Is there something I can do with 18? We just did it a minute ago. Write this as 3 times the square root of what? 9 times 2 plus 2 square root of 5 minus 2 square root of 2. What's the square root of 9? 3. So this first term becomes what? 9 square root of 2 plus 2 square root of 5 minus 2 square root of 2. Can any of those be combined? The first and the last one come in. What's 9 square root of 2 minus 2 square root of 2? 7. So the answer here is 7 square root of 2 plus 2 square root of 5. So far as I can go with that one. So they don't always all terms combine. You only figure out what are like terms and how they combine. Okay, just a few more and we're done. 3 times the cube root of 48 minus 2 times the cube root of 162. Off the top of your head, anybody know that one? 7, I don't know. Okay, what's my key? I have cube roots. My key is to organize what's under the radical to be perfect, what? Cubes, okay? So you just come off of here, okay, 48. How can I organize 48? All I know about 48 right now is an even number. Divide it by 2, you get a 24. Divide that by 2, you get 12. Divide by 2 and you get a 6. Divide by 2 and you get a 3. So 48 can be written as, what am I looking for? I'm looking for perfect, what, cubes. Do I see anything 3 times? Okay, I see a perfect cube here. So this is what, 2 cubed times 6, or 8 times 6. If you work these a while, you might look and say, oh yeah, of course, I knew 48 was 8 times 6, okay? But if you can't get to that to start out with, you can do the prime factorization. So that's my key to 48, is going to be writing it as 8 times 6. So this is 3 times the cube root of 8 times 6. Now, 162. What kind of number is it? It is even. So I'm going to divide it by what? Divide it by 2 and I get what? 81. And what do I know about 81? It's divisible by 3. Okay. So that's 3 times 27. Yeah, that's divisible by 3 and I get what? 9. So it's 3 to the 4th. Yes. It is the square root of 9, but I'm looking not for square roots, I'm looking for what? Cube roots, okay? So in this case, let me just get the factorization. Do I see any number here 3 times? I got 3 3s. What's 3 cubed? Yeah. So this is 27 times 6, okay? So I'm going to write this as 2 times the cube root of 27 times 6. And that first expression, what can go away? What can I simplify? The 8. What's the cube root of 8? 2. So I'm going to have 3 times 2 and the cube root of 6 minus 2. What can be simplified here? What's the cube root of 27? 3. And I'm left with the cube root of 6. So this is what? 6 times the cube root of 6 minus 6 times the cube root of 6, which is 0. Wasn't that a beautiful problem? You know? A lot of work to get a very simple answer, right? But the skill here is whatever root you have, you've got to be very skilled at organizing what's under the radical in those terms. This one happened to be cubes. Now, here's one. Before I get too far into it, can I just add those things to? Can anything be added together? Yeah, I've got negative 3 square root of 40 and negative 3 cube root of 40 and 2 cube root of 40. What would those add together to be? Negative 1 cube root of 40. So this is just going to be negative cube root of 40 minus 2 cube root of 6. Now I have to ask myself, cube root of 6. 6 is what? 2 times 3? There are no perfect cubes there. That's as far as I can go. What about 40? 40 is what? It's 20 times 2. Are any of those perfect cubes? No. It's what? 8? 8 times 5? Is 8 a perfect cube? Yes. So I can write this as the negative of the cube root of 8 times 5 minus 2 times the cube root of 6. Negative 3 times the cube root of 40 plus 2 times the cube root of 40 is what? Negative 1 cube root of 40. So what's the cube root of 8? Yeah, so I'm going to have negative 2 cube root of 5 minus 2 cube root of 6. Can I add those together? Yes or no? No, that's as far as this one goes, okay? Negative 2 cube root of 5 minus 2 cube root of 6. I think we have one more. Is that right? Excellent, excellent. Okay. Do you need a break? We can work the next one. You guys have been really good. Well, what time does the class end? 57. We've got time. Okay. 56. You stand corrected, Andy. Andy lied. Okay, can I just add all this stuff together right now? No. My key to this will be to organize what's under the radical as perfect cubes, okay? 48. Do I need to do prime factorization, or can you think of something? It's 8 times 6. 8's a perfect cube. Okay, I got that. 135, I'm not sure about that one. Okay, I'll have to see. Okay, let's look at 135. First thing I'm going to divide that by is what? 5, because it ends in a 5. So that gives me 27, And now you see the number 27, you start to recognize that. That's a perfect cube, right? What is that? That's what cubed? 3 cubed. So this is 3 cubed times 5. So that's going to help me, okay? So I'm going to write this as negative cube root of 8 times 6 plus 2 times the cube root of 5 times 27. What about that, the last term? Cube root of 5. Anything I can do there? No. What's the cube root of 8? 2. So this is negative 2 cube root of 6 plus, what's the cube root of 27? It's 3. So I'm going to bring this out and I'll have what? 2 times 3 cube root of 5 minus 3 cube root of 5. So this is negative 2 cube root of 6 plus what? 6 cube root of 5 minus 3 cube root of 5. Now what can be combined? Yeah, the 6 minus 3 is what? 3. So this is negative 2 cube root of 6 plus 3 cube root of 5. That's as far as we go. Okay, how does this feel? All right? Okay. Feels like Friday, huh?